Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started in today's video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. In this video, we'll be looking at Unit 7 on quadratic equations, Lesson 14, which is Part 3 of the Completing the Square lessons. The learning goal in this lesson is to complete the square for more complicated expressions. There's 2 learning targets in this lesson, and when we get done with the practice problems, we'll come back, review these, and ensure you've learned everything you needed to in this lesson so you're prepared moving into the next one. The first learning target says that you can complete the square for quadratic expressions of the form ax squared plus bx plus c, meaning standard form, when a is not 1. This is the new change that we're going to introduce in this lesson. Previously, the a was always 1, so we just had x squared. Now we're going to look at what happens if that a is not 1. Learning target number 2 says that you will be able to solve quadratic equations in which the square term coefficient is not 1, and you'll be doing it by completing the square. So the learning targets pretty much seem like the same thing. The previous 2 lessons we talked about the method for solving by completing the square, and now we're just going to make it one little bit difficult by changing the a from 1 to some other number and showing you how all of this is going to work together now. For glossary terms, we have completing the square. Notice that when it's an expression, the main thing is that we have a squared term. Now we're going to worry about that a being there because a is not going to be 1 anymore. And then we have this extra amount that's being subtracted. But then when we turn it into a quadratic equation, notice we've moved that amount over to the right side, because we always want to make sure that we start out with just the squared term on the left, and then we can go from there to solve it. The next glossary term is perfect square. And a perfect square is something that is created by multiplying something by itself. So 9 is a perfect square because it's 3 times 3. When we're going through the steps to complete the square, we're trying to create a factor that is being multiplied by itself. So maybe something like x plus 2 squared. And our last glossary term is rational number. Remember that when we refer to something as a rational number, we're talking about a number that we can write as a fraction. So obviously that means fractions are rational numbers. Whole numbers can be written as the whole number over 1. So whole numbers are rational. And then things like square roots or decimals, where when you get it into decimal form, it is either going to repeat itself in a pattern or it's going to have a stopping point. Those type of decimals can be written as fractions, such as 1/3, and therefore those are rational numbers. Now, some examples of what we would call irrational numbers would be things like pi or the square root of 2. Because when you try to put those into a calculator, what you'll see is a decimal that does not repeat in any kind of a pattern, and it does not stop. It'll fill up every position that your calculator will let it use. So just make sure you understand the difference between a rational number and an irrational number. Now we can begin the practice problems for Unit 7, Lesson 14. The first one simply wants us to select all expressions that are perfect squares. So first, let's look at the ones that are obvious. If I look at C, I have the factor 7 minus 3x being squared. That means it is 7 minus 3x times 7 minus 3x. So this is what we mean by a perfect square. If you look at D, you have 5x plus 4 and 5x minus 4. These are not the same. One is plus, one is minus. So this is not a perfect square. And then let's look at E. We have 1 minus 2x, and then negative 2x plus 1. So it's not the same order, but both of them are a positive 1 and a negative 2x. So, order doesn't matter as long as the signs are the same. And in this one, they are the same, so E is a perfect square. Now, let's look at the ones that are not so obvious. The ones that are written in standard form. So in standard form, for this to be a perfect square, here's what you need. Ax squared must be perfect square. You must be able to create ax squared by multiplying something by itself. Your C term must also be a perfect square. You must be able to create your C term by multiplying something by itself. And then your BX term must be 2 because you're going to multiply the linear term in one factor by the constant in the other. Then do the same thing with the other pair, so you're going to have two of them. So it's going to be 2 times the square root of your A term times the square root of your C term. So this is what we want to check as we do this. So let's check A. 9x squared can be created by multiplying 3x times 3x. So far, we're good. 16 could be created by multiplying 4 by 4 or negative 4 by negative 4. Since my B term is a positive, that would need to be positive 4. Now, if this is correct, then my B term would need to equal 2 times the square root of A, which was 3, times the square root of C, which was 4. 2 times 3 is 6, and 6 times 4 is 24. And that's what we have. So this is correct. If you want to double check yourself, 3x times 3x is 9x squared. 3x times 4x is 12x. 4 times 3x is 12x. And 12x plus 12x is 24x. Then 4 times 4 is 16. So because we can change it from standard form to factored form, and that factored form is one factor multiplied by itself, A is a perfect square. Now let's look at B. 2x squared would need to be a perfect square. But you cannot get 2x squared by multiplying something by itself. So 2x squared is not a perfect square. You can stop right there because you know at that point B is not a perfect square. If I tried to multiply x times x, I would get x squared, not 2x squared. If I went up one more and I tried to do 2x times 2x, I would get 4x squared. That would be too big. If that one ax squared term is not a perfect square, then the entire thing is not a perfect square. And lastly, let's check F. The first thing I see is that ax squared is a perfect square. I can get that by multiplying 2x times 2x. So we're good so far. Then I look at my C term. 9 over 4 is a perfect square. I can get that by multiplying 3 halves times 3 halves. But now we need to check the B term. The B term would need to be 2 times 2, because the square root of 4 we said was 2, times 3/2, because we said that is the square root of 9/4. So 2 times 2 would be 4. 4 times 3 would be 12. And 12 divided by 2 would be 6. And the b term does equal 6. So that means f is also a perfect square. If you wanted to check yourself, 2x times 2x gives you 4x squared, so we're good there. 2x times 3/2 is 3x. 3/2 times 2x is 3x. And 3x plus 3x gives us 6x, so we're good there. And then 3/2 times 3/2 equals 9/4. So this is a perfect square because the factored form is 2x plus 3/2 multiplied by itself. If you have any questions about how to solve any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2. Find the missing number that makes the expression a perfect square. Then write the expression in factored form. So, I'm going to make some notes here. Remember that the b term is going to equal 2 times the square root of a times the square root of c. So on number 1, I can see that a is 49, so the square root of 49 is 7. I can see that c is 16, so the square root of 16 is plus or minus 4. Since the b term is going to be negative, we're going to use -4. So that means the b term is 2 times 7 times -4. 2 times 7 is 14, and 14 times -4 is -56. So the missing number is 56. Now, in factored form, this is going to be the square root of a plus the square root of c squared. So we said that the square root of 49 was 7. So that's going to be 7x. And we said that the square root of 16 was going to be -4. So this is 7x minus 4 squared. If we want to check ourselves, 7x times 7x is 49x squared. 7x times negative 4 is negative 28x. Then we would do that again. So negative 28x minus 28x is minus 56x. And negative 4 times negative 4 is 16. So these are the answers to number 1. The b term is 56, and the factored form is 7x minus 4 squared. Number 2. The a term is 36. So the square root of that is going to be 6. The c term is 4. So the square root of that is going to be 2. That means b is going to be 2 times 6 times 2. 2 times 6 is 12. And 12 times 2 is 42. So the missing number is 42. When we write the factored form, that is going to be 6x plus 2 squared. If we wanted to check ourselves, 6x times 6x gives us 36x squared. So we're good on the ax squared term. 6x times 2 is 12x. And I'm now seeing that I wrote these numbers backwards. 2 times 12 is 24, not 42. As I was saying, 6x times 2 is 12x. Again would be 12x. So 12x plus 12x is 24x. So that gives us the bx term. And then 2 times 2 is 4, which gives us the c term. So these are the correct answers for number 2. Number 3. The ax term is 4x squared. So the square root of 4 is 2. The c term is 25. So the square root of 25 is 5. So the b term is going to be 2 times 2 times 5. 2 times 2 is 4. And 4 times 5 is 20. So the missing number is 20. Now when we write this in factored form, notice that the b term is negative. So this is going to be 2x minus 5 squared. Let's check the answer. 2x times 2x gives us 4x squared. 2x times negative 5 gives us negative 10x. 2 of those gives us negative 20x. And then negative 5 times negative 5 is positive 25. So this is the correct missing number, and this is the correct factored form. Number 4. We have 9x squared, so the square root of 9 is 3. We have 9 for the c term, so again, the square root of 9 is 3. B is going to be 2 times 3 times 3. 2 times 3 is 6, and 6 times 3 is 18. So the missing number is 18. Now in factored form, that is going to be 3x. The b term is positive, so that's plus 3 squared. Let's check our answer. 3x times 3x gives us 9x squared. 3x times 3 gives us 9x, and 2 of them gives us 18x. Then 3 times 3 gives us 9, so 18 is the correct missing number, and 3x plus 3 squared is the correct factored form. And finally, number 5, the a term is 121. So the square root of that is 11. The c term is 9. So the square root of that is 3. The missing b number is going to be 2 times 11 times 3. 2 times 11 is 22. And 22 times 3 is 66. So the missing number is 66. When we write it in factored form, the ax term is going to be 11x. The b term is positive, so it's going to be plus. And then the constant is going to be 3 squared. Let's check the answer. 11x times 11x is 121x squared. 11x times 3 is 33x, and 2 of those give us 66x. Then 3 times 3 is 9, so 66 is the correct missing number, and 11x plus 3 squared is the correct factored form. If you have any questions about how to solve any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 3 wants us to find the missing number that makes the expression a perfect square. Then write the expression in factored form. This is just like what we did previously, only now they want us to find the c term, and they're giving us the bx term. So let's think about what we've already learned. We know that we're going to take the square root of ax squared plus the square root of c and we're going to square them to create ax squared plus bx plus c. And we know that the bx term is going to come from 2 times the square root of ax squared times the square root of c. So what we can do is we can fill in what we know. For number 1, we know bx, that's going to be 42x, is going to equal 2 times the square root of 9x squared. Well, that's going to be 3x. And what we don't know is the square root of c. So that means 42x is going to equal 2 times 3x, which is 6x, times the square root of c. We're going to divide both sides by 6x. And that's going to give us 7 equals the square root of c. Now, if I want c, then the opposite of taking the square root of something is to square both sides. So if I square both sides, then 7 times 7 is 49, and that's going to be my c term. So this missing c term is 49. Now in factored form, we're going to have the square root of ax squared, which we said was 3x, plus the square root of c, which we just said was 7, and we're going to square it. Let's double check ourselves. 3x times 3x is 9x squared. 3x times 7 would be 21x, times 2 would be 42x, and then 7 times 7 is 49. So these are the correct answers for number 1. Let's look at number 2. Filling in what we know that bx is negative 28x. That's going to equal 2 times the square root of ax squared. The square root of 49x squared is 7x, times the square root of c. Two times 7x is 14x, times the square root of c. Now we divide both sides by 14x, and we get negative 2 equals the square root of c. If we square both sides, then we get 4 equals c. So the missing number is 4. In factored form, we need the square root of ax squared, which we said was 7x, plus the square root of c, which we said was -2. So we can rewrite this as -2. And we're going to square it. Let's double check the answer. 7x times 7x is 49x squared. 7x times -2 is -14x times 2 is -28x. And -2 times -2 is +4. These are the correct answers for number 2. Number 3. Bx is 110x. That's going to equal 2 times the square root of ax squared. The square root of 25x squared is going to be 5x times the square root of c. 2 times 5x is 10x. Now we divide both sides by 10x, and we get 11 equals the square root of c. If we square both sides, then 11 times 11 is 121. So the missing c value is 121. In factored form, the square root of ax squared we said was going to be 5x plus the square root of c we said was 11, and we square it. Let's double check the answer. 5x times 5x is 25x squared. 5x times 11 is 55x times 2 is 110x. And 11 times 11 is 121. These are the correct answers for number 3. Number 4. Bx is negative 144x equals 2 times the square root of ax squared. The square root of 64x squared is going to be 8x times the square root of c. 2 times 8x is 16x. Now we would divide both sides by 16x. 144 divided by 16 equals 9. So this leaves us -9 equals the square root of c. If I square both sides, then -9 times -9 is 81. So that is the missing c value. In factored form, we have the square root of ax squared which we said was going to be 8x, plus the square root of c, which we said was negative 9, squared. Let's double check the answer. 8x times 8x would be 64x squared. 8x times negative 9 would be negative 72x. Times 2 would be negative 144x. And negative 9 times negative 9 would be 81. These are the correct answers for number 4. And finally, number 5, bx is 24x. That equals 2 times the square root of ax squared. The square root of 4x squared would be 2x, times the square root of c. Two times 2x would be 4x. Now we divide both sides by 4x, and that gives us 6 equals the square root of c. We square both sides, and we get 36 equals c, so the missing c term is 36. In factored form, we said we have the square root of ax squared, which we said was 2x, plus the square root of c, which we said was 6, and we're going to square it. Double check our answer. 2x times 2x is 4x squared. 2x times 6 is 12x, times 2 is 24x, and 6 times 6 is 36. These are the correct answers for number 5. If you still have any questions about solving any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 4 is our last practice problem for this lesson. Number 1 is just like the previous practice problem. They're giving us ax squared and bx. They want us to find the missing c term, and then they want us to write it in factored form. So a couple of notes. We said that the bx term equals 2 times the square root of ax squared times the square root of c. And we also said that factored form was written as the square root of ax squared plus the square root of c, all of that squared. So let's take a look at what we know. In the first one, we have 4x as the b term, and that is going to equal 2 times the square root of 4x squared. That's going to be 2x times the square root of c. 2 times 2x equals 4x. Now we divide both sides by 4x, and we get 1 equals the square root of c. If we square both sides, then we get 1 equals c. That means the missing c term is plus 1, and the factored form is 2x plus 1 squared. We can always check the answer. 2x times 2x is 4x squared. 2x times 1 is 2x, times 2 is 4x, and 1 times 1 is 1. So this is the correct set of answers for the first example. Now let's look at the bottom one. Bx is negative 30x. That's going to equal 2 times the square root of ax squared. So the square root of 25x squared would be 5x times the square root of c. Two times 5x is 10x. Then we divide both sides by 10x, and we get negative 3 equals the square root of c. We square both sides, and negative 3 times negative 3 is 9 equals c. So the missing c term is 9, and the factored form is 5x minus 3 squared. Now let's check the answer. 5x times 5x is 25x squared. 5x times negative 3 is minus 15x, times 2 is minus 30x. And negative 3 times negative 3 is positive 9. These are the correct answers for the second example. So let's look at number 2. Number 2 wants us to solve each equation by completing the square. Well, we just found the first example right up here. So I know that I've got 4x squared plus 4x equals 3, but we set up here to complete the square, the c term is going to be 1. So if we added that 1 on the left, we're going to add that 1 on the right. And now we also already found the factored form, so we can write 2x plus 1 squared equals 3 plus 1, which is 4. So now we would take the square root of both sides, and the two answers would be 2x plus 1 equals positive 2, or 2x plus 1 equals negative 2. We would subtract 1 from both sides of both equations. This gives us 2x equals 2 minus 1, which is 1, or 2x equals negative 2 minus 1, which is negative 3. The opposite of multiplying by 2 is dividing by 2. So we're going to divide both sides of both equations by 2. And this gives us the final answers. X equals 1/2 and x equals negative 3/2. Next, we'll look at the second one. And up here in the table, we already did that. So the first thing we need to do is subtract 8 from both sides. This gives us 25x squared minus 30x equals negative 8. Now, to complete the square, we set up here on this bottom row of the table that we needed to add 9. If we add 9 on the left, we have to add 9 on the right. Now, we said up here in this second row that makes the factored form 5x minus 3 squared. And on the right, negative 8 plus 9 is positive 1. So we completed the square and we have our perfect square. Now we're going to take the square root of both sides. And when we do that, 5x minus 3 equals 1, or 5x minus 3 equals negative 1. We add 3 to both sides of both equations. That means 5x equals 1 plus 3, which is 4, or 5x equals negative 1 plus 3, which is 2. Then we divide both sides of both equations by 5. And we get the final answers. X equals 4 over 5, or x equals 2 over 5. If you have any questions about how to solve any part of this practice problem or any of the other practice problems that we went over in this lesson, please leave a comment below and I'll get back to you with any help that I can offer. Now let's go back and look at the learning targets and make sure you've learned everything you needed to be prepared before moving into the next lesson. We had 2 learning targets in this lesson, and they are pretty much the same. The idea was that you could be given a quadratic expression where a is not 1, And you would be able to complete the square and solve it. So we looked at a few things. The first thing was understanding where that bx term comes from. And we decided that bx is always going to equal 2 times the square root of ax squared times the square root of c. That's going to find the bx term. So as long as you understand that, you can plug in the information that you know to solve for the information that you don't know. The next thing we needed to understand was how to write it in the factored form. And what we talked about was that the factored form was going to be the quantity of the square root of ax squared plus the square root of c, and all of that was going to be squared. That would set up our perfect square. Once we got that far, we know that we simply take the square roots of both sides and we solve for x. Again, if you still have any questions, please feel free to leave a comment below and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see a link for another video that YouTube believes will help you. And in the bottom right corner of the screen, you should see a subscription button for the channel. Please subscribe to the channel, give this video a thumbs up, and I look forward to seeing you in the next lesson.